Okay, so we'll move on to the next topic. The next topic, I will review some of the set theoretic terminologies. You might have seen, or I should say you should have seen, some set theoretic terminologies before. But if you haven't, that's okay. We will be going over what we need right now. So what is a set? A set is just a collection of objects, and they will be called the elements. We are going to use capital letters to denote sets, and we are going to use lowercase letters to denote the elements of a set. Okay, so here is the notation that we are going to use. A, epsilon, capital A. So lowercase a, epsilon, capital A. So it's going to mean that small a is an element of cap A, or small a belongs to cap A, or we can say small a is a member of the set cap A. Okay. Now, how are we going to express sets? Well, if a set has only a few elements, then we can express the set by just listing out all the elements, right? I can just write out all the elements. So, if A has only few elements, let's say 0, 1, 2, 3, 4, then we may express A by just listing all of its elements. So we can just say that A is equal to 0, 1, 2, 3, 4 within curly braces. Okay. But a lot of the times we will express a set A by the following notation. We are going to write that A is equal to the collection of all elements X belonging to a bigger set S, and then with the colon sign, and then we're going to write out a membership condition. Okay. So after the membership condition is something that X has to satisfy to belong to the set A. Okay. So we will always assume that every set consists of elements from a fixed universal set S. Okay. And as an example, let's take cap A to be the set of all elements x in the rational numbers. So it's the collection of all rational numbers x such that x is between 0 and 1. So I have the condition here is x has to be between 0 and 1. And before that, we are specifying where x is coming from. Okay? What universal set x is coming from, and then I have the condition. Is that notation clear to you? I have another set here, B. B is the collection of all points x, y in R2. So R2 means, what is R2? R2 is the collection of all ordered pairs of real numbers. So this R2 is the collection of all points in the plane. So B is the set of all points in the plane such that both coordinates are non-negative. So in picture, what is R2? In picture, R2 is basically the first quadrant. R2 is basically the first quadrant, including the y-axis and the x-axis, right? So the set B is the set of all points in the first quadrant, including the points on the positive x-axis and the positive y-axis, right? Okay, C is the collection of all integers n such that cosine of n pi over 2 is 0. Cosine of n pi over 2 is 0. Can somebody tell me what are the elements of C? N has to be a multiple of 2. Okay, for example, if n is 2, you get cosine of pi. Is cosine of pi 0? Odd. Remember, cosine of 0 is 1. Cosine of pi is negative 1. Cosine of pi over 2 is 0. Cosine of 3 pi over 2 is 0. Or negative pi over 2 is 0, right? So anytime you have a odd multiple of pi over 2, right, cosine of that angle will be 0, right? So this would be the collection of all odd integers. So let me just say 2m plus 1 such that m is an integer. This is one way of expressing all odd integers, right? 2m plus 1. Is everybody okay with that? Okay, there is a special symbol. This is called phi. Some people say phi, but most people, I think, will say phi. And I think that's the right pronunciation. So phi is going to denote the null set or the empty set. Okay, null set or the empty set. What is the null set or the empty set? Well, this is the set with no elements. Okay, this is the set with no elements. definition of a subset. Given two sets A and B, A is a subset of B denoted by A. I'm not sure how this symbol is pronounced, but we are going to denote it by writing A with the horizontal U and B. So that's what I mean, that A is contained in B, or A is a subset of B. If every element of A is also an element of B. Okay. Let me, in fact, add equality there as well. Is that definition clear? A is a subset of B if every element of A is contained in B as well. Is it clear to you that if A is a subset of B and also B is a subset of A, then A and B are the same? Right? Two sets are equal if they have the same members. Right? Two sets are equal if they have the same elements. Right? So A is contained in B. That means all the elements of A are contained in B. B is contained in A. It simply tells you all the elements of B are in A. So they must have the same elements. Right? So A contained in B, B contained in A simply implies that A and B are the same sets. Are we okay with that? Now I want to give you a picture called a Venn diagram of a subset. So what is a Venn diagram? Venn diagram is a diagram like this. The rectangle, the points within the rectangle represents the universal set S. So all elements come from the universal set S. And then within that, I have the set B. The set B is within the set B consists of the points within the bigger circle, and the set A consists of points within the smaller circle. So when A is a subset of B, it means that A is contained in B, right? So the picture, I can visualize that A is a subset of B in this way. Is that clear? Okay. Let's look at this operation of union on sets. Given two sets A and B, what's A union B? A union B. I think that union that I have, union symbol U, I think it's called a cup. So A union B, also instead of A union B, you can also say A or B. Okay. What is the union of A and B? Well, the union of A and B is the collection of all elements of the universal set such that X belongs to A or X belongs to B. In simple terms, what this is saying is that A union B is the set of all elements that lie either in A or in B. Right? A union B is the set of all elements that belong to A or B. So basically, you are putting together all the elements of A and B in one bigger set. Right? Put together the elements of A and B in one bigger set. That's what the union is. Here's the intersection. given two sets A and B, A intersect B, that upside down U is also called a cap, A cap B, A intersect B, or you can also say A and B. A and B is the intersection of A and B is the set of all elements X such that X is in A and X is in B. In other words, A intersect B is the set of all elements that belong to both A and B. So you look at A and B, and you take the common elements of A and B. So A intersect B, or A and B, consists of the common elements of A and B. Is everybody clear on what I just said? Is everybody clear? I want to make a remark here. Suppose that I write down a set which is 1, 1, 2. Is that set different from the set 1, 2? Are they different? No, they are the same sets. Just because you are copying the same element a couple of times, so it's like if I look at the set of all students in this class, right, and say I copy one of you and write your name twice, does that mean I have a bigger set? No. A set is determined by its elements, okay, by its elements. So these two sets are the same, okay. Let's look at examples of the two operations. So A and B. A is the set 1, 2, 4, 7, 11. B is the set 3, 5, 7, 9, 12. Okay, somebody tell me, what is A union B? What are the elements of A union B? Yeah. 7. Okay, is that it? I'm talking about the union, not the intersection. What is A union B? What is the definition of A union B? Elements that belong to either A or B, right? Yeah, you just put together all the elements of A and B together, right? So what do you get? 1, 2. I get 3 from B, 4 from A again, 5 from B. Right? Is 6 there? No. 7. Remember, 7 will be rewritten just once because there is no reason why I should write 7 twice. And then I have 9, 11, and 12. Right? Do I have all the elements of A and B? Right? What is the intersection? The intersection consists of the elements that belong to both A and B, right? So what elements belong to both A and B? 7. Is everybody okay with that? Now, I can express union and intersection in a Venn diagram in the following way. So this is the Venn diagram, and by the way, how do you spell Venn diagram? Venn is V-E-N-N. And of course, everybody here knows diagram. Venn diagram. So again, the rectangle, the points within the rectangle will represent all the elements of the universal set S, and then we have two sets A and B, and they may have an intersection. So that's why I have overlapping region between A and B. So A union B is that yellow color? Can I say that yellow? Maybe. Okay. The A union B is basically the yellow region, right? It is the set of all points within A and the set of all points within B put together, right? How about the intersection of A and B? The intersection of A and B can be expressed in this way, right? The intersection of A and B here is the green region, right? Is the region where A and B overlaps, right? Is the region where A and B overlap. Okay? Alright, so let's look at another definition then. Disjoint sets. Disjoint sets. Two sets A and B are said to be disjoint if the intersection of A and B is phi, the empty set. A and B are disjoint if A intersect B is empty. In other words, what does it mean? It means that A and B are disjoint if they have no common elements, right? There are no elements that belong to both A and B. Okay? As an example, if I take A to be the collection of all integers such that x is even, and if I take B to be the collection of all integers x such that x is odd. So in other words, A is the set of all even integers, B is the set of all odd integers, well then A intersect B is empty, right? An integer can't be both even and odd, right? So A intersect B is empty. Instead of using the word disjoint, a lot of the times we use the word mutually exclusive. So when we say A and B are mutually exclusive, we simply mean that they are disjoint. Now, how would you express disjoint sets in a Venn diagram? How would you express disjoint sets in a Venn diagram? Right here. Right? A and B will not have overlapping region, right? A and B should not overlap. Any questions on disjointness? Okay, let's look at complement. Complement, given a set A, the complement of A is usually denoted by writing a overline on A, or by writing a C as a superscript on A. Okay. And what's the complement of A? The complement of A is the set of all elements X such that X is not in A. So the complement of A is the set of all elements that are not inside of A. Right? The complement of A is the set of all elements that are not inside of A. As an example, if I take S, the universal set, to be the set of all integers, if I take A to be the set of all even integers, and if I then, what is the complement of A? What is the complement of A? Well, the complement of A will be all integers that are not even. Well, that's exactly the set of integers which are odd, right? Now, how will my example here change if instead of Z, if I see the answer to my, I'm given the set A, right? And the complement of A is going to depend what universal set you have. So if you change Z with, let's say, the set of natural numbers, counting numbers instead of Z, how will that change? Well, that changes my complement, right? Now you're looking at the complement inside of the natural numbers. If I change Z to rational numbers, right, then you're looking at the complement inside of the rational numbers, right? Your answer is going to change, the A complement, right? If I replace Z with Q, right, A complement in that case will be all rational numbers that are not even integers, right? Well, that includes all the odd integers and more, right? Is that making sense? So when you're looking at the complement of a set, you have to know what universal set you are talking about, right? If you change the universal set, you are changing the complement as well, right? Is everybody okay? So maybe I should say the complement of A in the universal set S, right? Okay, so in a Venn diagram, this is how the complement looks like. So here, the yellow region is the set A, and A complement is everything in S, that's not in A. Everything in S that's not in A. Right? That's a complement. Is everybody okay with that? Did you guys need time to write this down? Okay, so I don't think we have seen this one yet. Set theoretic difference. Set theoretic difference. A backslash, right? This is backslash. A backslash B. A lot of the times people just write A minus B. So sometimes people will say A minus B. That's a little bit of a confusing notation because negative has a usual meaning to us for real numbers. So that's why you would rather use backslash instead of the minus sign. So what is that? A minus B is the set of all elements X such that X is in A but X is not in B. So what is A minus B? A minus B is the set of all elements of A that do not belong to B. The set of all elements of A that are not inside of B. In other words, how would you find A minus B? Well, to find A minus B, from the set A, kick out the elements of B. Then you will remain whatever remains will be A minus B. From the elements of A, take out the elements of B. Right? Get rid of the elements of B from A, and you will end up with A minus B. Is that making sense? Okay, so in a Venn diagram, how does A minus B look like? Well, A minus B is the red region. What's the yellow region? What's the yellow region in my Venn diagram? That's B complement, right? Yellow region is the B complement, right? And the red region is A minus B. So what did we do? Well, from the set A, we got rid of all the elements of B. So from the set A, get rid of A intersect B, basically, right? From A, get rid of A intersect B. You end up with A minus B. Now, you see that one way to express A minus B, one way to express A minus B is to say that this is the intersection of A with B complement. Do you agree with that? The intersection of A with B complement, is that exactly the red region? What is the intersection of A with B complement? B complement is the yellow region. What is the intersection of that with A? That's exactly the A minus B. You agree with that? So A minus B is the same as A intersect B complement. What will be B? What will be B minus A? B minus A will be A complement intersect B, same thing. Okay. Let's label in blue maybe. Or maybe this, what is this color? Maybe pink? Anybody knows what that color is? What's that? Purple? What is that? That's exactly B minus A, right? You agree? B minus A is that purple region. Now, I have one more line that I want to write down here. Someone please tell me what is A intersect B complement plus, or not plus, sorry, union A complement B union A intersect B. What is that equal to? What is that equal to? What is that? When you say everything, what do you mean? All of us? A, so basically I have A minus B union B minus A union A intersect B, right? What's that? A union of A and B, right? A and B together, A union B, right? Remember, A minus B is the red region. B minus A is the purple one. And then A intersect B is the overlapping, right? Overlapping region. Together you get A union B. One more thing. On the right hand side, the sets that you have, are they disjoint? On the right hand side, the sets that I have, there are 3 sets on the right hand side. Are they disjoint? Disjoint or not? Look at the picture. What's that? A minus B is the red one. The purple one is B minus A, right? Or you can say A complement intersect B. and then the intersection is in between, right? So aren't they disjoint? Right? They don't overlap. So they are disjoint. Okay, make sure you understand that because I'm going to use that later.